Hello, hello, hello. On this beautiful day, we are going to multiply matrices using scalar and matrix multiplication. So, by warm-up, Hafiz's Pizza Shop sells three types of pizzas: cheese, pepperoni, and supreme. And just so you know, there probably should be a colon right there. And here are the pizzas and the prices. So write this menu as matrix P. So there's more space over here, so let me write it as matrix P. And it's simply this. Remember, we drop all the units, and we just make sure to keep an order. Okay? So here I have 7, 9, and 12. That's it. And this, by the way, is a 3 by 1 matrix. The dimensions, 3 by 1. Next, if he needed to calculate tax, what would he do? So what would he do? Tax for each one of these? Well, he would multiply each piece by the tax rate. And here in Massachusetts, the tax rate is 6.2%. So he would have to multiply that by each of these. And we're not going to do that work now. We'll do that later. So there we go. Now, let's look at multiplication. The first component we're going to look at is called scalar multiplication. In geometry, when we speak of scale change, we mean that everything stays proportionally, particularly the sides stay proportionally the same, but the size increases or decreases, as the trapezoids here to the right show. So, just by way of an example, if this were 2 and this became 4, and this also were 2, then this would have to be 4 here. And I'm just making this one up, but if this is 4, then this would be 8. So notice what's happening, that everything is just doubling, and I don't know if those numbers really work, but double there, double there, double there, and double there. So the scale is a double. It increases in size by 2, each of the sides, while the angles there are remaining the same. So the relative positions are the same. Okay, so let's apply that to matrices as well. Scalar multiplication is the same for matrices. The entire matrix is multiplied by the same amount. So this is how we would write it. If this is my matrix 5, negative 1, 3, and 7, and I multiply by 3, notice all we do is just write 3 times the matrix. And another way of writing that, if this were an A, if this were just matrix A, then all we would simply say is 3A. Your calculator would have it like this with a bracket around it, but we don't use brackets when we write them. We just use a capital letter. And that's it. So we could simply say 3 times A, or 3A, is equal to, and then we do the individual products. The 3 times 5, then the 3 times negative 1, then 3 times 3, and 3 times 7 as written here. Now this part right here is sort of mental. You can skip this part and just do it. And jump to here. 15, negative 3, 9, and 21. So that brings us to scalar multiplication concept. To multiply a matrix by scalar C, lowercase because it's a variable, we multiply each element of the matrix by C. So if this is my matrix A, then each of these elements get multiplied by C, and that's it. The only difference between this and this is the C in front, or multiplying each element. That's it. So let's write the warm-up tax problem if the tax rate is 6.25% in Massachusetts. So I wrote that as a decimal. Now, the mental part, which we don't need to show, again, is this is going to multiply inside each part. So we get 0.0625, and that's times the 7. And the 0.0625 times the 9. And lastly, the 0.0625 times the 12. And what's our end result? We get approximately, and I'm going to change this because we're going to round here, we get approximately 44 cents. Then here we get approximately 56 cents. It's 0.56, 0.5625 but we're just going to round there. And lastly, this one's exactly 75 cents, but we'll still keep the approximate value there. And there we go. So if you want to see using a calculator, that's over here. And in fact, most of what you're going to work on later is going to be calculator based because this is tedious. The reason that our computers were invented is to speed up processes like this. Okay. Next, example 2. If A is this matrix and B is this matrix, what is 4A plus 3B? 4A plus 3B. So what we need to do, and I'm just going to write the first step here, is we have 4 times this entire matrix and plus 3 times this entire matrix. Now I'm showing you this step right here, but you're welcome to actually skip this and just jump straight to the next part here, because now this 4 gets distributed to all 6 of those elements right there. I'm not going to write the product part, I'll just write the end result here. So we get an 8, a 32, a negative 12, a negative 4, 20, and an 8 again. Then multiply the 3 everywhere. Negative 3, 0, 15, 0, 9, and negative 6. And lastly, when we are combining matrices, as we did in the previous lesson, it's the corresponding elements that combine. So there we get 8 minus 3, or 8 plus a negative 3. So that is a 5 right there. And now continue. This 32 plus the 0 is going to be a 32 there. Continuing on, negative 12 plus 15 is a positive 3. And keep going here. We have a negative 4 plus a 0, which is a negative 4. We have a 20 plus a 9, 29. And lastly, we have 8 and plus a negative 6, which gives me a 2. So here's my answer. 4A plus 3B is equal to this matrix right there. Again, scan this or check the link below in the description to see how to solve using your TI graphing calculator. So go ahead and take a moment and repeat that. Do the similar situation, but using your calculator here. What is 3A minus 2B? Make sure to pause and then come back and check. And there's the result that I got using my calculator. All right, the next component we want to consider is this. We want to know what the solution of this matrix equation is. 2x plus 3 times this matrix equals this matrix. So what do we do? Well, we're going to do similar things as we have done before. Like if I had 2x plus 3 times 2x minus 1 equals some expression here, my first step would be to distribute there. Well, that's what we're going to do here. I'm going to distribute essentially this scale into the matrix there. So let's do that, our first step. So 2, and I'm going to use a capital X here, plus, and write this as a matrix, 6, 9, negative 3, 12. And all that equals the 8, 5, 11, and 0. Okay. Now, I need to subtract this matrix right here from both sides. So whatever I do to one side, I need to do to the other. So, now I do want to show you that we're not really writing it under. Technically, we're writing it to the left here, or to the right here, and also to the right there. So, remember that when we are subtracting, then we are going to subtract the elements, the corresponding elements from each of these. So you could consider this as just take the opposite of everything in there, and then you can add them together, add the corresponding matrices down. So I'm going to bring down the 2x, and And all that's going to equal here, 8 minus 6 is a 2, 11 minus 9 is also a 2, 5 plus 3 is an 8, and a 0 plus a negative 12 is a negative 12. Okay, so now what? How do I get rid of this? Well, we often say just divide by 2, but divide by 2, that seems odd. Well, remember that dividing by 2 is the same as multiplying by 1/2. So I'm going to write in the front, multiply by 1/2, like so. So of course, those reduce, and I'm left with just my x. It's a large x. And then over here, all I have to do is divide each element using scalar multiplication, each element by 1/2, multiply by 1/2. So I get 4 there and a negative 6 there. So here's my final result. 1, 4, 1, negative 6. Go ahead and check that to show how we do this with a calculator. Okay, now this is your turn. Pause here and then check your work. Okay, let's see here. I am going to name these matrices, so that's going to be a 2A. So I'll call this one A and call this one B. And you can be more creative if you want to go like C, D, and E. Totally fine. Okay, so in order for me to get X by itself, because that's what I'm trying to isolate, I need to do 3X equals D plus 2A, because I add 2A to both sides. And then I need to multiply, and that should be a large X. I multiply by 1/3, D plus 2A. So punch that into your calculator when this is your A and that's your D. I said D, and I go back and make those changes. This is actually a B here, and a B there. There we go. And this is the answer that I got. Now the last thing we're going to go through is how to multiply more than one matrix, not just simply doing scalar, but matrices together. So let's return back to our original problem with Hafiz's Pizza Stop. Last week at lunch he sold 33 cheese pizzas, 45 pepperoni, and 11 supreme. At dinner he sold 74 cheese, 109 pepperoni, and 52 supreme. Using matrices, what was his revenue per type of pizza? So let's look at this. If we have the lunch and we have the dinner crowd, here's what happened. And up here, we're doing the cheese, the pepperoni, and the supreme. So we end up getting a 2x3 matrix there. So it's 33 here, 45, and 11 supreme. And then for dinner, 74, 109, and then 52. Remember what our other matrix was. The other matrix was a 3x1, and this one is a 2x3. The 3x1 was the cost of each of them. So we had 7, 9, and 12. Okay, what are we going to do? Well, logically speaking, if I wanted to know how much what was his revenue at, and actually let me change this here, his revenue for each meal. Okay, so $7 for cheese, $9 for pepperoni, $12 for the supreme, and then they all have to be added together. And then we'll repeat that exact same process down there. So that brings us to how to solve, what the algorithm we use. And it looks like this. It's a little bit confusing, but again, this is the benefit of matrices. Matrices are sort of small, but they pack a lot of information into them. Hence the reason we use calculators. As we consider all these operations that go into calculating the one element, let's see this rule. To find element Cij of the product matrix AB, multiply each element in the ith row, in this row, first, second, third, fourth row, of A by the corresponding element in the jth row of B, and then add the products. I know that looks really, really ugly, but look what happens here. These two here go up to there, multiply those two, and then they add together to get this right there. Okay, so it's best if I show you a small little video here, and I'm going to use animation for that. And here we go. So I've got this matrix, these two matrices, boom. Now, watch what happens. Okay, so that the 6 and the 2 come over and rotate and then multiply those guys there. Continuing on, and then they added together. Whoa, let's slow down here because there was a lot that happened here. So let's see what happens. So here we have our matrices. Now notice the 6 and the 2 are going to go up, and this is kind of just a mental thing. They slide up. Then they are going to multiply down those two right there, boom, and then they multiply those lower ones down as well, boom. So now we get the negative 24 and the 10. And our last thing to do is we do have to add them together. And there we go. Now let me also point out to you, this time, the dimensions, how the dimensions work. So let's follow along with these dimensions down here. The dimensions, 2 by 2 here, becomes a 2 by 1. Why? Because the middle component matches. The middle part matches. Let me explain what I mean by that again. Here. Because these two match right there, that means these two are going to be able to fit well up there. And the end result is almost like, it feels like the transitive property, where those two get scratched out, and we are left with the 2 by 1. We're left with the 2 by 1. And there we go. So the total, when we consider above, the total revenue, would be these numbers here. So that's what it looks like. And let me slow it down a little bit just to show you how things. Again, you can show with a calculator. It's very quick and easy. That video there shows you how to do that. Okay, so essentially what happens is the 6 multiplies those guys there, and the 2 multiplies those, and then we add them together. So let's see what we end up getting. So there's a 12 plus a 6, and then the 6 and the negative 4, those become a negative 24, and this 2 times that 5 is a 10. And then we finish it by adding together 18 and negative 14. So we see it's actually fairly quick. These two here multiply there, they trickle down and sum together. So it feels complicated, but yes, that's because there's a lot going on in matrices. Again, the benefit of working with matrices. This is just about entering data in and figuring it out on your calculator. So let's bring it back up to here and see what we get. So for each one of these, the 7 needs to multiply here, the 9 there, the 12 there. And then those get added together. And the 7 multiplies there, 9 there, and so it's as if we write the 7, 9, and 12 above, trickle those down, and write them as a sum. Again, this works. Why? Because this 3 right here and this 3 match. So my end result is going to be a 2 by 1. My end result is going to be a 2 by 1. So let's do each of these products real quick here. So this one is 7 times 33, and we get 231. Then a 9 times 45, and that gives me a 405. Notice I'm putting a sum in between them. And then the 12 times the 11, and that should be a sum there, and 132. And continuing on here, this 7 multiplies the 74, the 9 multiplies the 109, the 12 multiplies the 54. There we have. And the end result now is just summing things together to get a 2 by 1 right here. And now we answer the question, what was the revenue for each meal? So last week, $768 in revenue, and $2,000, so that's for lunch, and $2,123 in revenue for the dinner. If you wanted to know what your total revenue was, here it's just a quick sum. If you wanted to go further, you can add those together. So that brings us to solving matrices. Now please take a moment and practice this one and pause to check your answer. And this one ends up becoming 2113. Okay, now, again, TI calculator is much faster in doing these, but let me now walk through each component here. Now, if we have this 2 by 2 matrix and this 2 by 2 matrix, notice, I do want to point out to you, this is a 2 by 2 and this is a 2 by 2. So because these two match, the end result is going to be a 2 by 2 there. So we know that's my end result. It's going to be a 2 by 2. So let's see all that goes into when we do this by hand. Okay. So I like to consider this row multiplying this column, and what I consider is, look at this little map. What if I were to overlay those two? So I had this row and this column. Notice the intersection. The intersection is uniquely this element, which corresponds to this guy there. Now, same thing applies. What if I chose a different column over there? So I chose instead this column right here. Well, notice in overlaying it there, I end up with this element right here. So that's how I will approach this visually and show you what happens. In order to find this element right here, we need to take this guy, bring it over, multiply those two, and add together to get that. And if we drop this one lower and multiply those two, it would get this element. Okay, so let me show you step by step each component, and it looks, like I said, it's going to look kind of ugly, and you only need to do this one practice here and then once in your homework. That's it. So the -1 and the 0 goes there, and remember, we're going to be adding those together as we go down. So I am going to show all of that here. So we get a -1 times a 2 plus a 3 times a 0. And then let's go ahead and trickle that down. This is going to trickle down to the next one there. So we get a -1 times a -4 plus the 5 times the 0, or the 0 times 5. Okay, and now what happens next? So the 3, 4 comes over here, and remember what this corresponds to. Here's the 3, 4. So it's going to correspond to those two. And this guy there. So the 3, 4. So it's now 3 times 2 plus 4 times 3. And then trickle down to get a 3 times a -4 plus a 4 times 5. So notice, again, a 2 by 2 times a 2 by 2 ends up with a 2 by 2 because of the outer components. And now, individually, let's just add, multiply, and add. Okay? -2 plus 0. -2. 4 plus 0. 4. 6 plus 12. 18. -12 plus 20. 8. And there we go. Now check this by, again, scan this, and you can see how to do it with the TI much, much faster. So show your work now down here for multiplying D times A, and then check that with a calculator. And we are done. Have a great day.